Welcome back to everyone. A very warm welcome to all of you, my dear students. A very warm welcome to all of you. So, guys, I welcome you all on this channel, NEET Success Simplified, and I am Dr.Uma Shankar Sir, your physics educator. And guys, we are going to. So, in the last session, what we have seen, sir? So, in the last session, guys, we have seen the integration, right? लास्ट सेशन में हम लोगों ने इंटीग्रेशन देखा था. So in the last session we have spoken about the integration, right? So last session we have seen to some extent that what is the integration, right? We have seen to some extent that what is the integration. Okay. Okay, so now in this session we are going to see, or we are going to move ahead in the kinematics. We are going to move ahead in the kinematics, and we will be understanding the use of integration in kinematics. So last session we have spoken about the integration part. Okay, so this is a mathematical tool like the differentiation, which finds its use in the study of kinematics, right? In the study of kinematics. Now, similarly, it is like the differentiation integration also is very useful as far as the kinematic thing is concerned. Okay, okay. Now, please understand this. Please understand this. So, see, sir, we have learned about this previously. So, V is equal to ds by dt, right? Okay. Yes, sir, we definitely have understood it that velocity is the slope of displacement versus time curve. So V is equal to ds by dt. Okay. Now, can I write this equation somewhat like this? So ds is equal to v dt, right? ds is equal to v dt, and if I integrate this on both the sides, if I integrate this on both the sides, can I write that s is equal to integration v dt, right? S is equal to integration v dt. Now, please understand this. So if we had guys, if we had the displacement function with us, we can get the velocity by differentiating it. But what if we have the velocity? What if we have the velocity? Can we have the displacement of such motion? Yes, sir, we can have that integrating by integrating the velocity with respect to time. By integrating the velocity with respect to time. So see. So from, please understand this. So if we have displacement given, and if we want to have the velocity, we need to differentiate. But if we have the velocity with us and we want the displacement, then we need to integrate. And in the last session, we have learned that integration is the reverse process to the differentiation. And we have also understood some basic concepts of integration, some basic integral formulas, some basic algebra of integration. So let's start with the question, and I hope with the question you will be able to understand this better. So let's suppose V is equal to t plus 1. Now you want to find the displacement. So the live student, can you tell me what is going to be the displacement there? The live student. Can you tell me what is going to be the displacement? Yeah. So, sir, yes, sir, definitely we can tell. So, we just came to know that S is equal to integration V dt. Okay. Now, here we have the function of V, we have the expression of V. So, can we write integration of t plus 1 dt? Can we write like this? Yes, sir, we can write like this. Now, from here, if I integrate, what I'll be getting? I'll be getting t square plus t, and don't forget t square by 2 plus t, and don't forget about the constant of integration. So when we are integrating this t plus 1, we'll be getting t square by 2 plus t square by 2 plus t plus c. Understood? Understood? So, sir, this is indefinite integral. This is the integral which is having no limit. Okay, so whenever we are not writing the limit to the integration, we always get the constant of integration. This is something we learned in the last session of integration, right? So this would be the answer to it. Okay. Now, in the same case, if I say that find displacement, find displacement from 0 to 2 seconds. Find displacement from 0 to 2 seconds. Now, in this case, what you need to do? Sir, in this case, so sir, we are having to find the displacement between 0 to 2 seconds. Between 0 to 2 seconds. So what we can do, sir, I can integrate this function in the limits of 0 to 2. So when I integrate this function in the limit of 0 to 2, I'll be getting the displacement between 0 to 2 seconds. So from here, can I write t square by 2 plus c, and how to put the limits to it? Sir, it will be like this 0 to 2. It will be like this 0 to 2. Right? I hope it is fine to everyone. So when we put limit to the integration, okay, there is no need of constant of integration in that case. Right? So we know that also. Now what we can do, sir, we can put the values in this. Okay, so how we are going to put the values there? So how we put? So we put the upper limit first. So it is going to be 2 square by 2 plus 2 minus 0, right? Minus 0. So it is going to be 4 meter. So what is the displacement? What is the displacement? So I'm considering that the displacement is there in the unit of meter. Okay, so what will be the displacement? What will be the displacement? So the displacement will be 4 meter during this limit. I hope it is fine to everyone. Right? I hope it is fine to everyone. Okay? 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 Now, in the same question, let me reframe it. Now, please understand this. So, in the first the same concept can be used in multiple languages. Okay, you don't have to get trapped in the language, right? You don't have to get trapped in the language. The first thing that we do the integration, we just had the function of velocity, and then we had this integrated. We had this integrated. So when we had this integrated without the limit, we get to have the constant of integration. Okay, okay, like this. Then we had the limit that we are asked to find the displacement between 0 to 2 seconds. So in a way, we are having the limits in which we are supposed to find the displacement. So we put the limits, then there is no constant of integration. Now there can be one more thing. Let's take the same function. So let's suppose that v is equal to t plus 1 again. Okay, v is equal to t plus 1 again. And we need to find s, that is the displacement, at the end of 4 seconds. At the end of 4 seconds, if if initially body is at origin, if initially body is at origin. So when we have this body at the origin, okay, when we have the body at the origin, what we are having? Okay, so we have a function for velocity in terms of time, and we are supposed to find the displacement at the end of 4 seconds. And one more information is provided here, that the initially, okay, that is at the start of the motion, the body is at origin. I hope it is clear to everyone. Now please understand this. Now please understand this. So now to get the displacement from the velocity, we need to integrate. Okay, very well, sir. We know this thing. Okay, so we are going to integrate this function. Okay. Now when we'll be integrating this thing, we'll be getting t square, by 2 plus t plus c. Okay. Now sir, we want to find the value of this constant of integration as well. Okay. Now, this constant of integration, how do we find this constant of integration? So, we find this constant of integration. We find this constant of integration from the information, from the info or the information we have in the question. Okay. Okay. So what is the information given in the question? So if initially body is at origin. So when initially the body is at origin, if initially the body is at origin, okay, so we need to use some information given in the question. So like the point is, what is the point, sir? The point is that in order to get the value of the constant of integration, you need to look into the question only. Okay, the question will give you some information which will help you to find the constant of integration. Okay, now so what is the information? So if initially the body is at origin, so initially body is at origin, that means initially means that at the start of motion, so we can consider at that moment the time is 0. Okay, so from wherever you are supposing that the motion has started, at that point you can consider the time as to be 0. It just means that you are taking the measurements and you are taking the reference from that point. Okay, because we obviously know that time is 0, time is never 0. Okay, but that is your frame of reference, that is from where you are taking the reference of average. Okay, okay, simple. So now at t is equal to 0, the body is at origin. So body is at origin means that s is equal to 0, that the s is equal to 0. So when body is at origin, that is s is equal to 0, so we can place it here. So if I put s is equal to 0, t is equal to 0, then we'll be getting c is equal to 0. So this is also what we call as the boundary condition. Okay, so it is something in mathematics. So you do integration to anything. If you ever want to find the constant of integration, we need to put some boundary condition. Okay. Okay, so that means that boundary condition means that some information is given to you, or using that information, you are finding out the constant of integration. So here c is equal to 0. Now, if I put this c is equal to 0 here, the displacement function will become t square by 2 plus t. Now, we need to get the displacement at t is equal to 4 seconds at the end of 4 seconds. That means at 4 seconds. Okay, so when you want to get at 4 seconds, so it is something like instantaneous. Okay, what is the displacement at 4 seconds? Now in that case, all you have to do, you have to put the value of t, that is 4 seconds in this case, into this very expression. So it will become 4 square by 2 plus 4. So it will be 12 meter. It will be 12 meter. I hope it is fine to everyone. Right? Okay. Okay. So how, sir, we can find the value of the displacement at some time? So for that, we first be requiring the constant of integration, which we can find by using the information given in the question, right? I hope it is fine to everyone. Now, let's say v is equal to 2 times t. V is equal to 2 times t. So find the displacement at 3 seconds. If find the displacement at 3 seconds, if t is equal to 0, if t is equal to 0, okay, and body is 2 meter behind origin. Now can you try this question? Can you process the information here? Please do that. So the live students can tell me how to solve this question, how to deal with it. So sir, very simply we can do this question. Sir, how we can do this question? So we are having the function of velocity here. So what is the velocity given? So velocity is equal to 2t. So we need to find s at 3 seconds. If t is equal to 0, body is 2 meter behind the origin. So what is the position of this body? That means that initially when the motion has started, that is where the t is equal to 0. That is where the t is equal to 0. So at t is equal to 0, at t is equal to 0, the displacement, it is 2 meter behind. That means when time is equal to 0, the position of the body is minus 2 meter, right? Okay. So this is basically what is this information, sir. So this information is there to help us to find the constant of integration. So when v is equal to 2t, can we say that the displacement, it is equal to integration 2t of dt? Okay, because we want the displacement to be integral of it. So what is the displacement? It is going to be 2t dt. So it is going to be 2t square by 2 plus c, right? Plus c. So basically s is equal to t square plus c. S is equal to t square plus c. Okay, very well, sir. Now, in order to find the displacement at 3 seconds, sir, we definitely do want the value of c. So how can we get the value of c? So at t is equal to 0, the body is 2 meter behind. So at t is equal to 0, the body is 2 meter behind. That is, displacement is equal to minus 2 meter. So can we put it here? Yes, sir. So if we put s is equal to minus 2, t is equal to 0, we get the value of c. So c is equal to minus 2. Okay, so can I write s is equal to t square minus 2? Can we write so? S is equal to t square minus 2. Very well, sir. Now, what is the displacement at 3 seconds? So, it will become t is in place of t, we can put 3. So, it will become 3 square minus 2. So, S will become 7 meter. S will become what? S will become this 7 meter. So, what is the displacement at 3 seconds, sir? It will become 7 meter. Right? It will become 7 meter. Okay? Okay? I hope it is fine to everyone. Now see, v is equal to t square. V is equal to t square. Now when we have the v is equal to t square, so we'll be having a is equal to dv by dt. Okay, so if in case, you know, you know, so let's get to the some more concepts here. Now see, so we have learned, so till now what we have learned, so we know that in kinematics, important things are displacement, distance, speed, velocity. Okay. Now, sir, we have learned to reach to velocity from displacement and reverse order also. Like if we have the velocity, how to come to the displacement. Okay, how to come to the displacement. Now similarly, we have something more important to it. So we also know that the acceleration is going to be equal to dv by dt. So sir, we know that the acceleration is dv by dt. Now, if velocity we are having, if we are having velocity with us, we can have it differentiated with respect to t to get the acceleration. With respect to t to get the acceleration. Okay. Okay. So from here, can I have the velocity like this? So velocity is going to be integration a dt. Velocity is going to be integration a dt. Okay, integration a dt. Yes, sir. Yes, sir. We can do that. We can do that. So velocity is equal to integration a dt. Okay. So similar to what we have seen in displacement and velocity. So if the displacement is differentiated, we get the velocity. Now, please understand this. So when velocity is differentiated, we get acceleration. Now, when the velocity is integrated, we get displacement. So similarly, when acceleration is integrated, we get the velocity. we get the velocity, right? Okay, wonderful, sir. Wonderful, no problem at all. So let's solve a few problems to this also. So let's suppose we have a is equal to 3t square, a is equal to 3t square, and we need to find velocity at t is equal to 3 seconds if initially the body is at rest. Okay, so if the body is at rest, if the body is at rest, if the body is at rest, so we have to find the velocity here from the acceleration. Now please go for it. I'm very sure we can do it. So this is your question. Please try to do it. I'm very, very sure we can do it. Please go for it. Please go for it. So sir, how we can do it? How we can do it? So it is given that sir a is equal to 3t square. Now find v at t is equal to 3 seconds if initially the body is at rest. Initially the body is at rest. So how we can do it though? So we are having the function of acceleration. Now for finding out the velocity, so what we can do, so we can integrate this. So we can integrate this with respect to t. Okay. So let's have it integrated. So it is equal to 3t square. So it will become t cube. How come, sir? 3t square. So 3 will be constant. So it will be out of the sign of the integration. Then we have t square. It will become t cube by 3. So it is going to become v is equal to t cube plus c. Okay. Now it says that if initially the body is at rest, so initially the body is at rest, so that means when t is equal to 0. So this is what? This is the info given in the question. See, always, from where you will be able to find the constant of integration from the info, from the information given in the question. So here, so t is given to be 0. That is because it says initially. So initially that means in the beginning of the motion where we are considering t is equal to 0. So when t is equal to 0 guys, when t is equal to 0, the body is at rest. That means the v is equal to 0. So that means t is equal to 0. So in the end, what is this velocity? So it will become t cube plus 0. Velocity will become t cube plus 0. T cube plus 0. Right? So v is equal to t cube ultimately. So now they are asking you find the velocity at t is equal to 3 seconds. So when we put 3 here, so it will become 3 cube. So velocity will become 27 meter per second. 27 meter per second. I hope it is fine to everyone. Okay. Now, moving further, let's have one more question. So let's suppose a is equal to t square plus t plus 1. So find the velocity at, find v at t is equal to 2 seconds. Find v at t is equal to 2 seconds. If at t is equal to 1 second, body is, if at t is equal to 1 second, body is moving with 2 meter per second in x direction. Okay, body is moving with 2 meter per second in x direction. Can you try it? Can you try it? Or will you write negative x direction? Negative x direction. Okay, now let's try it. The live students can respond to me in the chat. Also, the students who are watching the recording of it may solve with the flow of the video. You may not have to, stop the video. Okay. So how we got to do this? How we got to do it? Do it. So sir, how we got to do it, sir? So we have the acceleration here, sir, and we want to move to the velocity. Now I hope this much is understood to you. This much would have been understood to you that sir, if from acceleration we want this velocity, if from acceleration we want this velocity, so for that we need to integrate. So sir, how we got to integrate? So we are having v is equal to integration a dt. Okay, so v is equal to integration a dt. So it will become t cube by 3 plus t square by 2 plus t, right? T square by 2 plus t plus t. Don't forget about the c, right? Hello, Shisai. So, Shisai, what we are doing today? So in the last session we have seen about the integration, right? Now in this session we are seeing that where we can use that integration in the concepts of kinematics. Okay, so you may try this question. Okay, so what we have learned, we know that the integration is a reverse process to differentiation. Okay, so we understand. So see what we have done. So see, from how we reach the how we get the velocity from the displacement. Sir, we get the velocity from the displacement by differentiating it. Now, from the velocity, if we want to get the displacement, we need to integrate it. So we have solved one, two questions like that. You can check the recording of it. Now we are talking about the acceleration. So see, acceleration, no problem, Shita. So acceleration is dv by dt, we understand now. So acceleration is dv by dt. That means that if you want to find the velocity out of the acceleration, you need to do the integration, because integration is reverse process to differentiation. We understand that, right? So velocity is integration a dt. So we tried a few questions. Now we want to try this. Okay. So simply from this question you will be able to understand. So see, the a is given is t square plus t plus 1. Okay. Okay. Now we can have it integrated to get the function of velocity. Now we know that when we are integrating without the limits, we are having a constant of integration c. So what I was trying to explain to you that in different question, how to use the data given in the question. Okay. Sometimes we have to put the limit, or like in this case when you have c, so you need to find the value of c, and the c is found by seeing the information given in the question. So what is the information in the question? The information is that at v is equal to, at t is equal to 2 seconds, sorry, if at t is equal to 1 second, body is moving with 2 meter per second in negative x direction. This is the information from which you can find the c. This is also what we call as the boundary condition. So what is the boundary condition? When time is 1 second, the body is moving with 2 meter per second in negative x direction. So that means that the velocity is minus 2 meter per second. The velocity is how much, sir? The velocity is minus 2 meter per second. Understood? Understood? Now, what we can do using this information, we can get the value of c. So, if I put the v in this and t is equal to 1, so we'll be getting 1 by 3 plus 1 by 2 plus 1 plus c. So, from here you can get the value of c. Can you tell me what is c? Can you tell me what is C from here? So whatever C, so let's check what is the C here. So we are getting 1 by 3, 1 by 2 plus 1. So it is going to be 5 by 6 plus 1, that is 11 by 6. That is 5 by 6 plus 1, that is 11 by 6. So it is going to be equal to minus 12 by 11. Just check it once. No problem, no problem, Shita. What do you think? This value of C is correct or not? So how we got it? Can you check the value of C here? Yeah. So from where we are finding the value of C? From the information given in the question, that if at t is equal to 1 second, body is moving at 2 meter per second in negative x direction. So that means when the time is 1 second, the velocity is minus 2 per second. Okay. Okay. So this is C. This is okay, let's see. So minus 2, 1 by 3 plus 1 by 2. So the LCM is going to be 6. And this is 2 plus 5. And this is plus 1 plus C. Plus 1 plus C. So from here, it will become 6 and 5. That is 11 by 6. And this is minus 2 plus C. So C is going to be equal to, okay, sorry, my wrong. Yeah. So it is going to be minus 2 and minus 11 by 6. Minus 11 by 6. So it is going to be minus 12 and minus 11. So minus 12 and minus 11, that is minus 23 by 6. Right? Isn't it? I think it is correct now. Is it or isn't it? I'm not very good. Yeah. C is equal to minus 23 by 6. Yeah. Okay. Okay. Yes or no? Do you agree? Yeah. So I have made the mistake previously. No worries. Minus 23 by 6. Right. Now this C value you can put back here in equation number 1. So when you put back it here, so we'll be having the function of V as t cube by 3. Okay. T cube by 3 plus t square by 2 plus t plus C is minus 23 by 6. Minus 23 by 6. So what you have to do, so what is given in the question? So we want to find the velocity at t is equal to 2 seconds. So here in this function, we can put t is equal to 2 and we can definitely get the velocity from here. Is it clear? Is it clear how we are using the integration in this? Yes or no? Please answer me. Brilliant. Yes or no? Yeah. So integration, see, simply when you have the function of acceleration and you want to find the velocity, you can integrate that acceleration. If you have the velocity, you want to find the displacement, you can integrate, right? Same way you can do. Now let's move to one more question, and I think you can solve multiple problem by or your own, right? Now let's try this one. Little bit challenging, but you can do it. Just think in a way that something you have to do. See, you have to use some basic mathematics there. Let's attempt. Let's try. I'm very sure we can do it. Please go for it. Very interesting. Please do it. Oh yeah. Please do it. 4 root 3. Yeah. Perfect. Perfect. Wonderful. Now please let me do it now. So very simple. So see, a is equal to x square, and we want to find v. So sir, we understand that v is equal to a is equal to dv by dt. Okay. Okay. Now what mistake people do? So they write like this. Sir, v is equal to integration x square dt, and then they write x cubed by 3. X cubed by 3. So this is wrong now. Sir, how, why it is wrong, sir? Because you are integrating it. You are integrating it with respect to, you need to integrate it with respect to t, and you are integrating with respect to x. So this is not the answer, na? This is not the right way. Okay. Now sir, what to do? So sir, see, what can we do? So x is what? X is what? So when x is 2 meter, so x is 2 meter, then x refers to the displacement here. Do you agree? X refers to the displacement here. So when x refers to the displacement here, when x refers to the displacement here, can I write this equation like this? Now please observe. A is equal to dv by dt. Okay. Now if I multiply divide it by dx by dx, can I write it like this? So what I am going to do, I am going to write it like this, dx by dt. So I have rearranged this expression, dx by dt. I am taking them together. Then we have dv by dx. So dx by dt is nothing but the velocity, and this is going to be dv by dx, isn't it? So many times people memorize this as well, but this way it comes from. Okay, so acceleration is equal to v dv by dx. V dv by dx. So now can I write it as a dx is equal to v dv? A dx is equal to v dv. Now a is equal to x square dx is equal to v dv. Now can I write, if I integrate both the sides, can I get x cube by 3? X cube by 3 is equal to v square by 2 plus c. So there must be two constant of integration. Now one on left hand side, one on right hand side. So this doesn't happen this way. So whenever you are integrating an equation, there will be only one constant of integration. It is not like that you are adding one constant of integration on the left or one constant of integration on the right. You don't have to do like that. Understood? Okay, so there is one constant of integration. Now, to get this constant of integration, to find this constant of integration, what can be done? So, constant of integration is found from the info given in the question. So, what is information? So, given that at x is equal to 0, the body is at rest. So, x is equal to 0, the body is at rest. That means velocity is 0. So, that means c is equal to 0. That means c is equal to 0, isn't it? Now, c we already have. So, ultimately, this relation becomes so v square by 2 is equal to x cube by 3. Okay, now what is the value of x? X is 2, so it will become 8 cube by 3 into 2 v square. So it will become, so 8 cube, that means 8 cube 64, 64 into, uh, 60, sorry, 8 cube, no, it is 2 cube, na? Sorry, my mistake. Yeah, so x is equal to 2, so it will become 8 cube by 3 and it will become v square by 2. Oh, 2 cube by 3 upon v square by 2. So it will become v is equal to 4 by root 3 meter per second. Yes or no? Okay. Now see, you can definitely add the limits, Shrisai, in this case because initially the body is at rest. But see, why I am doing this way? Because see, not in every question it has to be 0 at rest. Okay. So if it would have been written that x is equal to 2 meter, the body is moving at a velocity of 2 meter per second in positive x direction. So you have to follow this procedure. So why to understand one more process to solve one kind of a question? Are you getting my point? Okay. In this case, if you put limit 0 to 2, it would work. It will work. But not in every case it will work. Are you getting my point? Right? Okay. Okay. So see, simply, so see, that is why in the initially I have told you where to put limit. See, like in this question. See this part. So find displacement from 0 to 2 seconds. So here you can get the limits for clear. So you put 0 to 2. Okay, but whenever you have information in the question, it is always advisable that you find the constant of integration and then solve the question. Okay, okay. Now, can I say that we will be able to use the integration to solve such kind of a problems? Right? I hope yes. Now, one more thing. It's a very popular equations of motion. Okay. So, sir, we know about it. Okay, yes. So equation of motion are very important in the kinematics. So what are these? So V is equal to U plus AT. So S is equal to UT plus half AT square. Okay, and V square minus U square is equal to 2AS. Right? So these three equations we have to do rectification, that is memorization. So you need to do memorizing it. You must memorize it by your heart. This is extensively used equation in the physics. So you need to memorize it. Okay. But from where these equations are developed? So these equations are developed from integration or using the mathematical tools only. Okay, let me show you that. Okay, because we are talking about the use of integration and differentiation. Also, in this, V is final velocity. V is the final velocity. U is the initial velocity. U is the initial velocity. Okay. T is the time. Okay. S is the displacement. What is it? Sir, S is the displacement. Okay. Okay. And A is the acceleration. A is the acceleration. Now, one very important point with respect to these equations. So, we'll be using it in coming sessions. I'll be just deriving it today. Or in coming session also we'll be using. So, in the next session, I'll be coming up with the graphs and kinematics. Okay. So, in the next session also we won't be using it. And after that, I'm thinking to come up with one or two sessions of vector. so that we start with motion in a plane together. Because after graphs in kinematics, we need to move with the motion under constant acceleration. Now, one thing very important about these equations, in these equation A, for using these equation, A is constant. A is constant, right? So A, if in any chance it's not constant, you cannot use this equation. Remember that. Okay. So these equations are only valid when we are having a body subjected to constant acceleration. And also when we say this time, it is basically the time period of acceleration. Are you getting my point? It is time period of acceleration. So just remember that. And see, you have to memorize these equations by heart. Understood? Understood? Okay. Is that clear? Now let's do some derivation to it. So why we are deriving? It's just we want to see the use of differentiation integration in kinematic. That is the reason why we are deriving them. So we know A is equal to dv by dt. A is equal to dv by dt. So from here, can I write dv is equal to a dt? dv is equal to a dt. Yes, sir. Now, if I integrate it, so let's suppose some motion started having initial velocity u and final velocity v. So that means this is to be integrated between limit u and v. And let's suppose the motion started initially at 0 time, obviously, and it reaches the final velocity at t time. So this function of t has to be integrated between 0 to t. Now from here, what is the integration of 1? So 1 integration means v. V, and when we are putting the limit, it will become v and u. And what is a? So a is constant, and this is 1. So 1, that is t, and the limit to it is 0 to t. So can I write it like this? So v minus u is equal to at, or v is equal to u plus at, isn't it? So this is the first equation of motion. Okay. Now in the derivation, you can see that a is considered as constant. Otherwise, this wouldn't be the relationship. Yes or no? So do remember this fact. Do remember this thing. Okay. Now, sir, we also know. Let's move to the next page. Sir, we also know. We also know that v is equal to ds by dt. Right? V is equal to ds by dt. So ds is equal to v times dt. Can we write so? Yes, sir. Definitely. Because you see, na, she say, see, kinematics question for IIT level is at a higher side of the NEET level. Are you getting my point? They are relatively higher side. Okay, but see, I see till now whatever we have learned here on YouTube, if you try to solve those questions, definitely you will be able to do. Right? But if complex integration differentiation involved, you may not be able to do. But conceptually, you will be able to address it. Isn't it? Isn't it? Okay. So later I'll give some advanced questions also in the class to solve some questions. Not because see you understand, Nashri, the level of NEET physics and level of JEE physics are very different. For advanced, it is a very high level physics. High level, not high level. See, what is the difference? Those who are going for IIT JEE, they are reading math as one subject, isn't it? So they are expected to know much of mathematics, okay, than you guys. Yes or no? Secondly, they are entering into the domain of engineering, okay. So they are expected to use practical concepts of the physics in their future career also. Okay, so this is the big difference. So this is a known fact, common knowledge that NEET physics is at a lower level to IIT, Advanced and Main. And see, we are running a batch of our NEET. If I start teaching here to the level of JEE Advanced, you understand this, that will be of no use for the NEET aspirant. Okay. So you have to, as a teacher, we have to draw some, boundaries when we are teaching in the batch of NEET, when we are teaching in the batch of JEE. Are you getting my point? Okay. And you are saying the main questions we can do. So main questions level is still a bit higher to the that of the NEET, but they are almost similar. Okay. Okay. Right. Okay. So let's move up. So now we understand that ds is equal to vdt. Now please tell me, can I take v constant or not? When I am integrating it, so it will be s here. Okay, so can I take v as constant or not? So definitely, sir, we cannot take v as constant because we just came to know that v is equal to u plus 80. So it is not constant, but it is the function of t. Now I am going to have it integrated between 0 to t, right? 0 to t. So can I write as is equal to, so when I integrate it, I'll be getting ut plus half at square. And since we are putting limit to it, there is no need of using the constant of integration. So this is your famous second equation of motion, isn't it? Yes or no? Very, very simple. Very, very simple. Okay. Now, now, sir, we understand that acceleration is equal to dv by dt. Okay, dv by dt. So can I write it as again the same way I'm going to do? So ds by ds. So can we write ds by dt? If we write ds by dt together, it will become v, and this is dv by ds. So we are getting acceleration as v dv by ds, v dv by ds, right? Okay. Now can I write a ds is equal to v dv? Okay. Okay. Now can be integrated both sides. So a is constant, so it will become s, and if I integrate this, so initial velocity is u, final velocity is v, so it will become v square minus u square by 2. Okay, how come, sir? So v integration is v square by 2, and when I put limit to it, that is u and v, so I'll be putting the values of v and u into it. So it will become v square minus u square by 2. So what we'll be getting? We'll be getting v square minus u square is equal to 2as, and that is your equation of third equation of motion. Okay. Okay. So see, right now I just have derived them and I request you to memorize them. Memorize them anyway. Right? Understood? Okay. Okay. Right. So and in these equations, A is constant, T is the time period in which the body is subjected to this constant acceleration, and F is the displacement. Remember, F is the displacement. It is not the distance, but it is the displacement. So we are going to use these equations when we will come up with motion under uniform acceleration, motion under constant gravity. All this will be dealing with. Okay. But in today's session, I tried to tell you that what is the use of integration, what is your use of differentiation, and what is the interrelationship between these quantities, how you can get one quantity from the other through differentiation, when to do the differentiation, when to do the integration. I hope this is fine to you. So in the next session, I'll come up with graphs in kinematics. Okay, graphs in kinematics. So this is going to be very, very important topic. Okay, very important topic, because you must have seen a lot of questions are getting asked from this particular topic, and this is a bit tricky also. We need to understand something, but I'll try to make it as easy as possible for you guys. Okay. Okay, so we are going to have the next session of graphs in kinematics, and after completing the graphs, I'll start with the vectors. Okay, I'll take 2 or 3 sessions. I'll try to take it, somewhat 2-3 hour sessions, and I'll try to complete the vectors because that will be required to be used some extent of it when we'll be moving towards the two-dimensional thing, relative velocity thing. So when we'll move relative velocity in 1D, simultaneously we can do the relative velocity. Uh, Shreya, I'm trying to end it by the month of March. Okay. So I'll be picking up 2 topics, like I'm going to pick up the vectors now. So that is motion in the plane will be picking up. Okay. So afterwards, once I start the Newton law of motion, parallelly, I'll try to start with somewhat similar topic. Maybe, properties of solids. Okay. It's quite similar. There also will be using the forces, right? So I'll try to club two topics and we'll try to do like that. Okay. Okay. So that is, I'm trying to complete the syllabus as early as possible, right? Okay. So you see that every day I'm coming up with one session at least. So as I told you that we also have limitations. of timing, that how much we can spend on YouTube, right? Okay. So anyway, we are trying our best. Harsal is also trying to finish that. And one more biology educator is coming on board very recently. So you will be seeing her lectures also. Okay. So that way your biology syllabus will be getting covered, okay, in a quick manner. Then it will depends upon you. The ball will be in your court. Right now the ball is in our court. Right. That's how early you can finish the syllabus. But when one more educator is going to come down the channel, you will be seeing that the channel is giving you more of the content than what you can cover, right, in time. Okay, so this is going to happen till now. Till then, you can cover up as much as you can. You can solve all the questions like that. Yes, bio definitely, when two teachers are teaching, definitely is going to end sooner. Okay, but physics also I'll do. Okay, okay, I'm talking to the team. We may come up with 2 sessions a day, or we can increase the time limit also. So I'm into it, I'm onto it, but it is not the right time to commit anything in this regard unless we have something firm with us. And the 75-day challenge is also going to start from Monday. Okay, as promised previously. So from Monday, we'll be coming up with the question session. If you are unable to join the live, you can always see the recording in fast mode to solve the question. If you are unable to solve anyone, you will be able to, yeah, yeah, Shizai. We are looking into it seriously. So you can do that also. So what you have to do, you have to keep practicing, keep revising. Okay, and some topics you can do by yourselves also, so that when we reach to that point, you will be more able to understand that, right? Okay, okay. So in the next session, we'll start with the graphs and kinematics. So please don't miss that session. Okay, because that is going to be a very very important chapter, a very important part of kinematics. And you see lot of questions are asked in the graphs and kinematics. Okay, there are many hacks, many short tricks to it, which will be helping you to answer the questions very quickly without making any silly mistake. So please try to come live, okay, in this session, so that you can keep asking the things, and definitely we'll go to do so. So tomorrow's class will be at 3 p.m. So sometimes what happens that you don't get the update, but I start at 3. Okay, only on Wednesdays I have some other engagement. So on Wednesday I don't come up at 3 p.m. Okay, otherwise every day I'll be taking the class at 3 p.m. Right? Okay, for next few sessions I can commit so. Okay, in a long run, even we don't know. Okay, but for time being, we'll be starting at 3 p.m. Okay, so with this, thank you very much. All of you who are watching the video recorded session, please like the video, please comment on it, please share to your friends. Please don't forget to subscribe the channel. Okay, and we'll see you in the next session with graphs and kinematics. Have a good day.